Unit 4, Quadrilaterals and Polygons. Lesson 4, Rhombi and Squares. Your objectives for this lesson are to identify properties of rhombi and squares as well as to apply these properties to solve problems. Okay, so first, let's talk about what a rhombus actually is. A rhombus is a quadrilateral with 4 congruent sides. So here, A, B, C, D. Since all 4 sides are congruent, as shown by these little tick marks, it is a rhombus. A rhombus is also a special type of parallelogram. Therefore, they have all properties of parallelograms. So, for instance, opposite sides are congruent, opposite angles are congruent. Other properties of rhombi are that the diagonals are perpendicular and that each diagonal bisects a pair of opposite angles. So I'll draw that up here for you. If I draw my diagonals, that's AC and DB. They are perpendicular, so they meet at a 90-degree angle here. And there's 4 90-degree angles. And this diagonal bisects the angles that it extends from. So, for instance, DB, ABD, and CBD are equal. So these two are also equal, congruent. And then these pairs of angles are congruent. Okay, so the diagonal splits the bigger angle into 2 equal pieces. Okay, a square is something I'm sure you've heard of before. It is a parallelogram with 4 congruent sides and 4 congruent angles. So this should have you thinking 4 congruent sides, rhombus, 4 congruent angles, rectangle. Well, a square is both a rectangle and a rhombus. Pretty cool. And if you remember back to the quadrilateral family tree, you'll see that the square's parents, if you'll call them, it has arrows pointing down from both rectangle and rhombus. It is both. So 4 congruent sides and 4 congruent 90-degree angles. Okay. Rhombi have all the properties of, oh gosh, not rhombi, squares. It should be squares. Have all the properties of parallelograms, rectangles, and rhombi. Squares. Okay. Example 1. In rhombus ABCD, this one, the measure of angle BAC is 32 degrees. That's marked right here. BAC, 32 degrees. Find the measure of each numbered angle. So we'd find 1, 2, 3, and 4. Okay, well, 4 actually might be the easiest one for me to find here. I know that the diagonals of a rhombus meet at 90-degree angles in the middle here. So let me make an answer box first. Okay. So since those meet at 90-degree angles in the middle, the measure of angle 4 is simply 90. Okay. From here, I'm going to say, let's find angle 1, because this is a triangle. So I know there's 180 degrees in a triangle, minus 32 degrees for here, and angle 4 we said was 90. So this is 180 minus 122, which is 58 degrees. So angle 1 is 58 degrees. Okay. Now we can find angle 2 quite easily. I know that the diagonals bisect the angles. So angle 1 and angle 2 are congruent, making angle 2 58 degrees. Now, measure of angle 3. Well, the opposite angles are equal. So this is equal to this. A and C are equal. And the diagonal bisects these angles. So down here we have 32 degrees, and this will also be 32 degrees on this side. So all four of those are 32 degrees. Angle 3 is 32 degrees, and this is my answer. Okay, these are some theorems that we're going to use in the next example. The first one says if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So this is a property we looked at before, now it's just written as a theorem. The next one says if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So if your opposite angles are bisected, you have a rhombus. And if one pair of consecutive sides of a parallelogram are congruent, then you have a rhombus. So not just opposite, but also consecutive sides. And if a quadrilateral is both a rectangle and a rhombus, then it is a square. Okay, so keep these things in mind while we look at example 2. Example 2. Determine whether a parallelogram ABCD with vertices A, -3, -3, B, 1, 1. Let me label these. So 1, 1, -3, -3. C, 5, -3. And D, 1, -7 is a rhombus, rectangle, or square. So we need to figure out which one of these this is. Well, I know that a square is both a rhombus and a rectangle, so I'm going to focus on those things first. And I know the opposite sides are going to be the same length because it's a parallelogram. I know that they're going to have the same slope. It's a parallelogram. Let's look at something else, something that is uniquely rhombus or rectangle. We're going to look at the diagonals. So I want to know, first of all, are these diagonals the same length? Because in a rectangle, the diagonals are the same length. So we're going to use the distance formula to check that. Remember, D equals the square root x2 minus x1 squared plus y2 minus y1 squared. So let's find BD first. And I'm going to label x1, y1, x2, y2. So square root x2 is 1 minus x1 is 1 plus y2 is -7 minus y2 is 1. So I have here the square root of 0 squared plus -8 squared, which is 0 plus 64. And the square root of 64 is 8. So BD is 8 units long. Now we need to find AC. Okay. So square root of x2 is 5 minus x1 is -3, so plus 3 squared, plus y2 is -3 minus y1 is -3. So I'm going to write a plus there. And I have 5 plus 3 is 8. -3 plus 3 is 0. And once again, I have the square root of 64 which is 8. Okay, so my diagonals are equal, which means that this is a rectangle. However, we need to check and make sure if this is also a rhombus, then we have a square. Okay, so it's definitely not just a rhombus. We have either a rectangle or a square. So I'd like to use the diagonals again here. And I know that in a rhombus, these will meet at a 90-degree angle, which is something that we check with the slope. So let's find the slopes. And m is y2 minus y1 over x2 minus x1. We're finding the slope of each diagonal. So let's find the slope of BD first. Okay, so we're going to have -7 minus 1 for our y's over 1 minus 1. Okay, and on top we have a -8. On bottom we have a 0. This is a problem because you cannot divide by 0. Our slope is undefined. Okay, but let's see what the slope of AD is. So we're going to have y2 minus y1, so -3 minus -3. And minus negative is a plus positive over 5 minus -3. And minus negative is a positive, so it's plus 3. So we get 0 over 8. Now, this is 0 slope. We have a horizontal line and a vertical line. Those are perpendicular. This is the only case where the flipping the sign doesn't quite work, but you do see that we have a 0 on bottom here and a 0 on top here. We do have perpendicular lines. So this is a right angle, which means our diagonals are both the same length and they meet at right angles. So we have both a rhombus and a rectangle. We have a square. Okay, so my conclusion here is, since the diagonals and that's BD and AC are both the same length and perpendicular to each other, A, B, C, D is a square. That is my conclusion for example 2. Okay. And that wraps up lesson 4.